All right. Good evening, everyone. My name is Rahul Krishnan. I'm an assistant professor in computer science and medicine at the University of Toronto. I'm going to tell you a little bit about what we should do with AI. So I want to thank the Walrus as well as Universities Canada for inviting me to this event. So my day job involves quite a lot of teaching, and I kind of describe it as follows. I teach humans how to build AI, and I teach AI how to think a little bit more like a human. So AI might evoke, quite a few strong reactions here. It might evoke reactions of hype, fear, confusion, excitement. So instead of asking the question what AI might do to us, tonight I thought I could ask, what should we do with AI? So I'm going to tell you about three things. I'm first going to tell you a story about how past technologies have changed societies. I'll tell you about how we arrived at today's AI systems and a little bit about what I do. And third, I'll tell you about what we should do next, or where we should go from here. So let's think back to ancient times, where a merchant might be tallying a shipment. And to do this, they might resort to hiring someone, a scribe, or using tally sticks to try and figure out the size of the shipment. Now, this process was slow, prone to errors, and was limited to small shipments. And then, across time in civilizations around the world, there was a simple invention, the abacus. So this thing was just a couple of rods and beads, but this invention changed quite a lot. It enabled us to externalize working memory, making arithmetic fast, repeatable, and error-resistant for everyone. The consequence of this invention was that it enabled larger-scale commerce and new avenues for individuals to participate in trade when they otherwise might not have been able to. And just as the abacus transformed how we handle numbers, modern AI systems represent another shift today in how we think about information. So I want to zoom forward in time now to 2010. And at that point in time, there was a competition called the ImageNet competition, because scientists wanted to figure out, can we teach a computer to recognize objects from images? And this was a really hard problem back then. I know it doesn't seem that way right now, but to tackle this problem, we threw everything we had at it. We spent a lot of time designing custom algorithms that tried to mimic how a human might solve this problem in order to detect an object from an image. And it turns out that this was not quite the right direction at all. The approach that ended up working was pioneered by Jeff Hinton at the University of Toronto, was instead to let a program figure out the algorithm from data, which is come up with an algorithm on its own as to mapping from images onto its objects. So this competition was won by Jeff Hinton in a landslide, and it kicked off what we know today as the deep learning revolution. Fast forward another decade or so, there was a small startup in 2020 by the name of OpenAI that ran a similar experiment. They took all of the text data they could find on the internet and said, what if we trained a very, very large neural network to predict the next word in a sentence given all the other words? That was the genesis of what we know today as large language models. So these LLMs, and I'll use them interchangeably with the word AI, were created at that time. And in many ways, for those of you who've used ChatGPT, Gemini, Claude, you've seen the sort of power that they have in terms of answering general purpose questions, not just with text, but with images, sound, videos. They truly are general purpose technology. But the same model that can sort of write a haiku about me being stranded in London due to an airline strike is also just unable to tell me how many collisions there were in a billiards table. That's weird. Why is that? Well, that is a simple enough question for any human to look at a video and figure out. Well, it turns out the mechanisms that these models use in order to make predictions are vastly different from how humans learn. So while we've let these models learn on lots and lots of data, the kind of learning that they've achieved is very different from our own. So if you or I walk into the kitchen and see a pool of water on the floor, we might think to say, oh, maybe the fridge is leaking. Maybe the dog knocked over a bowl of water. But LLMs might say, well, maybe there's a mop nearby and the floor was recently mopped. Why is that? Well, in the text data that it was trained on, often the word wet floor was closely correlated in space with mops. So it turns to that as a potential cause. And so in short, today's AI programs are excellent at spotting patterns, but they're really terrible at understanding why things happen. And this is the fundamental challenge that my group and I are working on. So we've recently developed a new kind of neural network called causal PFNs. And like many models before, this model leverages a large amount of compute. But this model learns to tease apart association from causation using millions and millions of simulated examples. And the really cool part is that it actually works on real data that it's never seen before. And so we're really excited to see how this opens up new doors for AI systems to tease apart cause and effect. We're actively studying how well such models can assist oncologists in prescribing chemotherapy after surgery for cancer. We're looking at whether this model can assist in predicting the effect of genetic perturbations, as well as figuring out if we can teach robots a little bit about cause and effect too. But as with all journeys like this, and I'm confident this kind of technology will eventually make its way with LLMs, I think it's really important to step back and ask where we're going. Which brings me to the final question that I'll highlight tonight. What choices should we, and when I say we, I mean really as a society, make as these systems get more and more powerful with time? My contention is that first, we should start becoming comfortable with change. So in the Industrial Revolution, we mechanized physical labor. In the coming years, I think we're going to see an increasing amount of digitization of cognitive labor. But if you've read any history book, the transitions during the Industrial Revolution were not smooth. And I think this is the reason why we have to proactively have these conversations. Second, we have to think about the kind of society we want when accurate knowledge is cheaply available, because that's where the world is headed. In medicine, we need to think about how we build AI-assisted healthcare systems. But not just building that system, thinking about how it ensures an improvement to our status quo, values patient outcomes, as well as equity of care. In education, scientific inquiry, business, manufacturing, we need to create the North Star that we want to move towards. And to borrow a phrase from hockey, skate to where the puck is going to be. Third, I think the biggest wins from AI are actually going to come from its dissemination throughout society. Just like the abacus, with every individual having access to this and using it as a cognitive scaffold, that's really when we'll understand its limits, as well as how far we can go with this technology. So AI is, to me, just a tool, just as the abacus once was. If we engage early and ensure that everyone benefits from this technology, I'm confident that we can expand human potential. And to me, the future is honestly not just about AI or how it evolves. It's really about us, the people and societies that we turn into through the process of this evolution. And so hopefully, in 100 years from now, someone like me will say in a room like this that we made some of the right choices. Thank you.